So topic for this morning session is called input and output and how it works in Java. And plan for this presentation is to tell you about input-output streams. There are also classes called streams in Java, which are not input-output stream, but which are data streams used for functional like programming, about files, readers, writers, about standard input, output and error streams, stream redirection, and I will mention object serialization and deserialization, which may be useful for your teamwork. And before we look in details about computers and Java programming language particularly, here is simplified model about inputs and outputs for thing called engineer. Hopefully it is also relevant for software engineer, but as far as I can tell, this model actually shows real engineer like engineer for building tangible things like cars, ships, buildings and bridges. So you can look on this like as a black box, which on this sticker actually looks like a yellow box, where it has two different inputs, problems and coffee come in, and solutions come out. And it has side effect like a sarcasm or cynicism or whatever. And this is quite simple but quite true model, because different kind of psychological studies show that these people who have technical mindset and who pay more attention to things, not to other people, they of course may offend more sensitive people more easily, and they usually look on things what other people may consider more cynical approach. And this model also is paraphrasing of saying what was told by one French, one mathematician, I think Dijkstra, and he told that a mathematician is device which converts coffee into theorems. So that's about inputs and outputs, and I have talked about inputs and outputs on this funnel, imaginative funnel already. For example, for programming language for data flows, it's very important to understand how data come in, how data come out, and what are constraints for your design, for example, to not get compilation or runtime errors when you change them a little bit. And here is very similar model which shows something completely different. It shows how you can develop programs which uses the standardized inputs and outputs to maintain data flow which you need to handle and process somehow. And initially I tried to do this with some GNU utilities, but I'm not so experienced for this and usually something went wrong, so I will show it with some other tool which I know approximately how to use in command line. And what is idea? That these programs which uses this standardized or standard inputs and outputs to process, each of these programs reads something from standard input, which usually is, if you do not do redirection, is your keyboard. And they write something in standard output. If they write, there may be programs which do not read anything from input, provides only output, and there may be programs which do not write anything in output, they read only from the input, but this output is console or terminal. And there is other stream of data as an output, which is not for usual cases, but unusual cases is standard error output, which is also directed to your terminal and console. And what is terminal? Initially, terminal was a physical device to connect to computer, and this may be good example. Oh, it's from Wikipedia. So, that is original computer terminal, not the oldest one, because before such cathode ray tube terminals, you still had keyboard connected to the computer, but output was not cathode ray tube terminal, but printer on paper. And what does terminal mean in these days? You had computer somewhere in basement of building, very large box, maybe few large boxes using entire room or even several rooms, and then they had connections to the terminals using different protocols, but one of leading protocols was RS 232, I think, if I remember the number, but RS is definitely one. And what these terminals had, they had output device, older computers printer on paper, newer computers cathode ray tube as a display and a keyboard. And so they could send characters from keyboard and they could receive characters to the terminal. So these were actual terminals approximately 50 years ago. And these terminals were not computers. If they had some processing power, this processing power was used only to handle these keyboard presses and convert them into proper stream of data to send about pressed keyboards, and only so much of processing power, for example, to remember what you need to show on this display until it is cleared out, because, for example, this real computer sent you few characters to print on this display, and of course printer remembers it because it's printed on paper and remains there. But for this cathode ray two displays, they had small amount of random access memory, so what was written there, then for each refresh of this terminal, of course all these characters still persisted there. And then, of course, microcomputers were then somewhere in between, where these were called computers. Retrospectively, they were renamed as mainframes. Then mini-computers were introduced, and then microcomputers. which was IBM PC compatible hardware. And you could attach terminals to them using still the same transmission cables, but usually you had directly attached terminal to them, directly attached the keyboard to them. And so initially many of these PCs didn't support many terminals and didn't support many users in difference with real computers, but then when they started supporting multiple users, etc., device called virtual terminal was introduced. And virtual terminal is software running inside your computer, which you can see not here on dedicated device, but you can see it here in this window. And where is difference? Difference is that it lives inside it's shown of course on my physical display. It reads from my keyboard, but this handling of stream of data from my physical keyboard and back to my display lives as a software, because I can now open many terminals. Each of them emulates this VT100, and if you will look here, when VT100 terminal was introduced, it is approximately 1970s, the standard, and you look on your virtual terminal help about. It still in some settings may say about backward compatibility with VT100, and VT of course means virtual terminal. This particular doesn't mention VT100 anymore, but all these sent data forward and backward are still compatible. So if you look through the wires, then all these terminals we have running as a terminal emulator programs are still very compatible with VT100. It is extended VT100, but all basic operations are still the same. And of course later for Unix-like systems they introduced graphical terminals, and for example what we see in Linux based operating systems, this x.org package maintains this in exchange with data to your computer using this protocol for graphical terminals. But here we will talk mostly about these text-based terminals. And so that's about what terminal is and why the software is called terminal emulator. And so these programs which uses these standardized streams of data or standard input-output to handle them, they work in such way that they read from keyboard, provide output to your terminal. And what is console? Console is built-in terminal in like a furniture. So in more precise, that would be actually terminal, not console, but they are used as synonyms. And that's how it works. And then for redirection, you may also need to know that these streams are numbered. For example, when you need to redirect, that standard input is numbered as zeros, input standard output as first, and standard error output as a second. You may create more inputs and more outputs with larger numbers, but these first three ones, starting with 0, are standardized as a number of these data streams. And so now about demonstration. So one of applications which I know how to use in terminal is eSpeakNG text to speech synthesizer, and it reads something from standard input, it provides something to standard output and standard error output, and the side effect for this particular application is produced sound, because produced sound invokes sound card of your computer, and of course invoking sound card of computer is not this old school standard to use. It is used a little bit differently, but I will show that even sending sound can be used using standardized inputs and outputs. And how does it work? If you call it and you do not pass any parameters, so you just write it's executable, and of course you can install it on your virtual machines as well, something like sudo apt install eSpeakNG. So you can install it and then you call it. And if you do not pass any arguments after it, so you do not add something here as additional words for additional information, it reads from standard input and then invokes your sound card of your computer. And I hope you heard Hello World from this synthesizer. I may make this. And it reads until it reaches end of stream, and in this terminal you say that end of stream has reached pressing Ctrl D, and Ctrl D is not specific character like null character for C strings. Ctrl D is signal for operating system, and operating system then through this command line interpreter, and then in this command line interpreter it signals like end of file. It sends event to this reader that end of file is reached, and in this case end of file is actually data stream from standard input, but it's still considered like virtual file. But then you can add some, and it doesn't print anything in standard output by default. Then you can add some parameters to it or arguments. For example, you can change language, which is -voice or -v, for example LV. And then it produces different sound. And then we have changed this behavior using these passed arguments. Then we can say, for example, do extended debugging or print out something in standard output. And then it produces something in standard output. In this case, it writes out rules about decision, how particular text is interpreted and how the sound is generated. And of course, particularly for English, where there are many homonyms, and particularly for French, where there may be hundreds of different suffixes for words which are still just A at the end or nothing at the end, these rules are quite complicated. So that's about passed arguments and about standard output. And then, for example, it prints something in standard error output, like this error. How can we know, for example, that I see it's still in my virtual terminal, but how can I distinguish standard output from standard error output? One of things is redirection. For example, I can say redirect second stream to the device called null device /dev/null. And this is also a nice feature of Unix-like systems, that all devices, almost all devices, are also reachable through the virtual file system. There are hundreds or thousands of virtual files and virtual folders in Unix-like system, which are actually entry points to your physical devices. And one of such virtual devices is like device which eats everything up, doesn't produce anything. In short, we can call it like a black hole. And if we redirect this second stream here, we see there is nothing. Produced. But if we say redirect it to some file, then here is produced this output into this file. And if there is just something in standard output, I wanted it to redirect it. Then I do not see anything in the terminal, but if I check what's inside file, I see here this output. Similarly, you can redirect as an input. So here I have a file called input.txt which has following content. And if I say, for example, read from this file, it reads from this file and use it as an input. So this is redirection of output stream, and this is redirection of input stream. And then I can add, for example, debug and redirect it to out.txt. I still see or hear this side effect, but now this program read from standard input and produced something into standard output. Particularly for this application, you may exchange or interchange reading from standard input and taking parameters. For example, if last parameter is not last words of this application is not parameter, like doesn't start with dash or dash dash, then these last words are used as a instead of input. So then if last word for this particular program is not considered parameter, it is considered as an input which is used to produce this sound. And for example, if you also use redirect input, you see that this is actually ignored because this is what is overriding this particular redirection, because then it means do not use standard input, use this last word as passed as a parameter or argument to this application. So now, and besides larger than, you can also do following redirection: larger than, or larger than, and this means do not overwrite existing file if it exists, but append only new log at the end. And then you see that it appended a new thing here, and then you see that new things were appended at the end of this file. So that's about redirection. And so how do you decide when you need to mention these numbers of streams and when you don't need to mention? You are not required to mention numbers of streams if you redirect input, then by default stream number 0 will be used, or standard input. And if you redirect output, then you are not required to mention number of stream if you want to redirect standard output or stream number 1. But if you want to be very ceremonial, explicitly you can say something like this, that append stream number 1 to this output txt. And similarly, if you do not have last word as a parameter for this program to execute, and then remember that these words are not considered part of arguments for this program. These words now are talking about redirection of streams. So you can say something like redirect stream from this file. Why it didn't work? That's interesting. Maybe something like this. So that works, but it should work all. It's 0 stream, sorry. Yeah. You should remember. And sometimes, depending on your interpretation, sometimes you are allowed to add spaces around this, sometimes not. Why? It depends on what is considered word and how these words are handled for this particular program. So, safe approach here is to not add spaces after redirection, because then some of these words may be taken up as additional parameters or arguments for this application which you are invoking. So zeros redirect as input, something like this. So, and this is the same as that, because zeros stream is default input and first stream is default output. But if you have some kind of problem with errors, then of course you can redirect, for example, this error. And then sometimes in Bash you can see something like this. first stream is redirected like to the file, and second stream is appended to the first stream. What does it mean? And here order is important, that first you redirect first stream or standard output, and after that redirection you may say that second stream, which is error output, actually should be added to the redirection of the first stream. And sometimes you may run it as a background process like this. So Bash has, or all these families of Unix shells have strange syntax. So this ampersand here as end means run it as a background process. So that's about redirection. Now about pipes. Pipes are very important part of dealing with standard inputs and outputs because they are very powerful. And for example, with command ls I can print in standard output list of all files, but I can also do this with pipe, which means redirect output of this program as an input to that program. So pipe means actually funnel after funnel after funnel. So you have many apps which takes something from input, provides output. With pipe you provide this output as an input to another. With other pipe you pipe it to input as another as many times as you like. And for example, here you can say word count, and you see 3 lines, 3 words, 26 characters. Or you can sort them. Or you can sort them and then word count. Or you can list them and say it in words using eSpeech-ng. Something like this. Or you can say word count dash only lines. Then it says in voice 3. And you will see pipes quite a lot in different kind of simple packaging automation, building automation, etc., where you write different kind of shell scripts to invoke all these different kind of GNU utilities for your needs. And for example, one of them is that this particular eSpeech-ng also might say produce something into the sound STDO instead of doing as a side effect. We can say that please send this data to produce sound into standard output instead this side effect. And then we see the binary data, which are actually bytes which need to be sent on sound card. But if we say, for example, read from the standard output and redirect it to Pulse Audio player, then we actually have sent this produced sound or bytes which should be sent to the sound card into standard output and then redirect it to Pulse Audio player, and it works in the same way as invoking it directly. And in such way, for example, you can send your sound through the network to some completely different computer. So that's about pipes. And that's it about demonstration. So how does it work in Java? In Java it works in following way that you should already know that there is Java object called system. .in is input stream, .out is this output stream, which is actually print screen object, and system.err is standard error stream. And particularly in integrated development environment like Eclipse, to see that error stream is different from the standard output stream, it is shown in different colors. For example, what we can read here, we can read few bytes here. What is wrong with that? That is wrong. And then we can read 1 byte here. And then and this throws exceptions. And we can put everything here in try block. And when we try to run it, so and this is okay, if we would call it char. But we cannot read chars. Okay, let's leave it as a byte. And here we may print out just the zeros byte. Zeros. And maybe then we will see the same output here for this read string. Okay. How do you convert byte to char? Maybe in such way. Okay, so we left it here. And what is also interesting is here you can see race conditions happening between two different streams, error stream and output stream. In my code here, first what is written out is a standard output, which is black, and then standard error output, which is shown red. But because these are two streams working in parallel, competing with the same virtual terminal here in Eclipse in this console view, because it's race condition, sometimes it may print it in proper order, like output first, error output last, but sometimes it may print it in opposite order. That this error is first and output is last. And this is one of very simple ways to see race condition happening between these two different streams which competes to the same resource here in console. And of course, the same thing you can do here in the terminal. And what are main classes which you may need in Java working with standard input and output? First, different kind of streams. I will show it later, their genealogy. Then file object, which you use to manipulate file system objects in operating system. Different kind of readers to read this stream of data. Different kind of writers to write this data. And when you deal with these streams of data, you always actually send stream of bytes from one place to another. In difference with some physical devices like serial devices, minimum amount of data you can send through this stream is 8 bits or 1 byte. So you can't read or write less amount of data than 1 byte. And then you can organize or aggregate them in different ways. For example, if this stream of data is actually a stream of characters, then you organize them by 2. If this stream needs buffer, then you use buffered stream, and again you need buffer to improve your performance. And then you may convert read bytes into string using scanners, or you can convert Java strings into written bytes using formatters, and then you can use data stream to use different kind of binary data or object streams, for example, to read-write objects. And every time you deal with many inputs and outputs, sometimes there is some confusion. What is input, what is output, especially when output is connected to another output. Remember that usually you are not confused to understand about input and output of house. Because if some people comes in, you consider they came into this house, and if they come out of house, you consider it coming out. So inputs and outputs are regarding to this box. This means your particular program. And when you need to handle input, you read, and when you want to provide output, you write. And it's similarly in everything else. For example, for sound systems, etc., equipment, inputs, reads, and outputs provides something. For example, you put your guitar in input and you connect this output to your amplifier. And so that's about readers and writers. And then in Java, usually you connect stream handler to stream handler to stream handler for different kind of needs and purposes. First, for abstraction needs, because when you read some data into your software, you may be reading it through the network, through file system, through standard input and many other things. So you need something like merging flow of data through one particular data handler, and then you may add more specialized data handlers or readers in this case to read for more and more specific sources, and you will see how this works also in your practical exercise. And then always you have to add buffered readers and writers in almost all of the cases, because without buffering you will have problems with latency. For example, if we have old school rotating magnetic drive HDD, so it has aluminium platter, at least one rotating here, and then it has read-write heads, usually two in both sides, and then you can read and write data from it. So this head is moving, actually it's swinging, not moving in such way for more modern disks. And then this is rotating and you can read-write some segments and sectors on this disk. And these disks are rotating, let's say, fast disks with 15,000 rotations per minute. This means one rotation takes, who is good at arithmetics? Let's say 10 milliseconds for one particular rotation. And if you have simple stupid application which writes 1 byte for each iteration on the hard disk, so it goes in some iterations, let's say calculates numbers of p, and each iteration provides one another number to be written, and this particular 1 byte is sent to the hard disk. And then next iteration comes and another, and if this disk has latency approximately 10 milliseconds, which needs to be for one full rotation here, in worst case scenario, proper place where you need to write it into disk may be immediately after reading writing head, so you need to wait full 10 milliseconds until available part of disk is under read-write head, and only then you can read. And of course, if you are very lucky, you don't need to wait at all, because this particular sector of disk is under read-write head immediately. But on average, it means you will need to wait like 5 milliseconds in average. And if you think that 5 milliseconds is small amount of time, then you can start calculating how much of these numbers you can write on your disk. So we have 1000 milliseconds in the second, you have approximately 5 milliseconds waiting time, so you divide 1000 by 5, how much do you get? I think you get 2 numbers per second, which you can write in a such way. Or if you take that it's 1 byte, this means 200 bytes per second. And of course, real speed of disk is, let's say, approximately 50 megabytes per second, or maybe even more, let's say 100 megabytes per second. And of course, there are many very fast high-end disks which may even write gigabytes per second. And why it's so slow? Because most of times this disk is doing nothing. you are waiting while this disk will be ready to read in particular place on this disk. Therefore, if you collect your... and one more thing which is very important, that here your program works like a character device. You send one character or one byte one by one, but disks are block devices. They do not address less amount of memory than single block, and the single block, depending on operating system you use, file system you use, etc., maybe 2 kilobytes, maybe 4 or even 8 kilobytes. For example, if you use old Windows with very large hard disk, old Windows cannot use many addresses to address this disk. This particular block can be 8 kilobytes, and if you have one single byte in your file, it still will waste almost 8 kilobytes of data because it cannot address less amount of memory inside this than this block. And if you change one particular byte into this block, what is actually happening is that it reads entire block, let's say 4 kilobytes of data, then replaces this entire block only one single byte in it, and then write entire block again. And because of latency and because disks are block devices, not character or byte devices, why it's all called character? Because in C, character and byte is the same. Then you need to collect everything in buffer, and if you collect everything in 4 kilobytes of buffer and you write it at once, you will still need to wait approximately 5 milliseconds for disk to be ready. But when it will be ready, you can very quickly write 4 kilobytes of data with this speed of disk, like 50 megabytes per second or 100 megabytes per second. So it will take, I do not know, few another milliseconds to write such amount of data. Therefore you need to do buffering. And if you think that the solid state disks are much better, they are a little bit better because their latency is lower, but they need to collect this charge into these cells, and they still have latency. Only difference is that this latency is smaller. So therefore you almost always need to do buffer and reading, writing. And similarly, I will show you later that you need to do this also for networked devices. And therefore, practically in Java, what is happening is that every time you read or write something, you construct several readers and writers in a row. A typical example is, for example, here. You create buffered reader and you pass as a parameter to this buffered reader input stream reader, which reads input streams, and you send as a parameter for this case system.in. But if that would be file, like reading from file, then it is very typical that you have 3 constructors to read from file. First, you create buffered reader to deal with latencies and make things faster. Second, you create file reader because you will read not from input stream in this case, but from file. And then you create a file handler or proxy object between Java world and actual file in operating system in its file system. So one constructor, another constructor, and third constructor. So this is very typical for Java. Now about these precise types. Here is class diagram, which is proper class diagram in this case. How different kind of input streams are specialized, for example for files, for objects, for pipes, for filtered where you can filter some data out immediately, for string buffer, byte error, etc. Remember, Java is strongly typed language, statically typed language, not statistically, but statically. So type should be told during compilation time when you just write code. And then you use, and here is class diagram of output streams. Again, depending on how do you structure data and what is your target, or in this case, target for output streams and source for input streams, then you need to use different kind of subtypes of these output streams. And similarly, readers are overloaded in Java, like many different kind of utility methods. So this means particular reader may take different subtypes of parameters to read from, but still it is typed. And for example, you need buffered reader to deal with latencies, and similarly, I told you how you can write very slowly, but similarly, if you will just read byte by byte from hard disk or network, again it will be working very slowly because of these latencies involved in a disk. And then, depending on how you want to aggregate these, collect these data together, you can, for example, look on them of array of characters or a string or other things. And similarly with writers, you can write strings and write array of characters or whatever. And system.out in general is a writer which writes a stream of bytes, but you can pass different kind of parameters to it, and then of course this will be converted into stream of bytes implicitly. And here is example which should work, and you can test it out. For example, how you read from standard input. And here is example how you can deal with file system objects. And everything in Java is instance or object of file system object. So files and folders are still file objects. Only difference is that if it's file, for example, its boolean is file returns true and boolean is directory returns false, and vice versa. If it's directory or folder, its file returns false and its directory returns true. And only difference is, for example, that if it's file, you can get, for example, parent, it will be folder. And so if you deal with folders, they do not have actual content, but you can deal with everything else with folders similarly to the files. And sometimes you need to deal with paths to file systems objects. What is important about paths is, I think I have a slide here. About shorthand notations or how you represent folder inside folder inside folder as a string. Of course, when you talk about file system objects, these are actually quite complicated data structures, which you can say in business terms, there's folder inside folder inside folder. In practical terms, of course, this means there's folder referring to another folder, referring to another folder. But important thing, how you can deal with this structure inside structure or structure referring to structure, converting it to just plain string. And then when you deal with this, you use delimiters, how to say that there is folder inside folder inside folder. And in Unix-like systems, this delimiter for string is normal slash. And I can change my current working directory like using, and nothing will change because that was my working directory before, what I see here on this command prompt. So here it shows current user, here it shows computer on which I am working, and here it shows current folder. And then there is specific meaning for this delimiter together with dot. Dot and this delimiter means current folder explicitly, and for example I can change, I can change the current folder again is this. It means change the current folder, nothing changes. Or so if I have folder inside folder, I can say change directory starting, and this is more ceremonial way to write on it, which means current folder still, and writing something this is not the same as writing something this. Difference is following, that simple dot means current folder, dot and slash means current folder in less ambiguous, more ceremonial way. And why this is important? Because if I say like, and here next character is not delimiter but something else like letters A, I'm actually creating a file which is named .aaa. So here it is, and here I have file named .aaa, and I have folder named aaa. And for example, but if dot is followed by this delimiter, then I can change to subfolder, and I can again change my subfolder to cd bbb, that would be, and parent folder is dot dot, or dot dot slash if you want to be more ceremonial, less ambiguous. And cd bbb is the same as cd dot slash bbb, so dot and slash has different meanings than dot and any other character, because dot and any other character means hidden file in or folder in Unix-like system, but dot and slash means current folder explicitly. And if I'm very ceremonial, I must say slash at the end to say explicitly that I want to change to the folder or directory, not to the file. And similarly, I can write dot dot in more ambiguous way, because if after dot comes some character, it is considered file, not folder. But if I'm very ceremonial, I can say cd dot dot slash. And so just to review, meaning of dot depends if it's dot and delimiter like slash, it is current folder. If it's dot and something else, it is hidden file folder. If it's dot dot, I think it do not depend so much, because but still I think you can also rename your file dot dot something. Let's say yeah, so it again depends. if it's dot dot slash in Unix-like system parent folder, if it's dot dot else hidden file or folder. Then about absolute path. So in Unix-like systems, everything starts not with C colon backslash blah 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 or D, but everything starts with slash. And you can refer to folders in two different ways, using relative path or absolute path. For example, I can say cd aaa, then I'm using relative path. And this is shortcut or shorthand notation. This means if there is directory aaa, it will be changed. But if I want to be very ceremonial and unambiguous, I can write dot folder aaa. So this and that is absolutely the same. Only is that in one case I mean current folder implicitly, in other case I mean current folder explicitly. But I can also change directory using absolute path starting from root of the file system, like /tmp, etc. So, and if it starts with slash, it is absolute path. So it starts from root folder. Now about difference for operating system, everything what I told you about slash in Unix-like systems, Linux, MacOS, BSD, etc. It is backslash for VMS and Windows. And here you may sometimes get confused because you read some Java guide which is intended for Microsoft Windows, and they say something like create file, let's say in folder IAA, subfolder BBB, subfolder CCC, file test.txt. And then I can change directory to this folder, and there is no such file. Why? Because of this meaning of delimiters, backslash is allowed character to be in name of file and folder. And remember, the dot and anything else than delimiter is just hidden file. And instead of creating a file named test.txt in subfolder AABBBCCC, I actually created hidden file with funny name. And by funny name I mean not standard name. So name for this file is dot backslash AAA, backslash BBB, backslash TCC, blah blah blah. So these backslashes are just normal characters, and that means they didn't have this specific meaning, delimiter, to show folder inside folder inside folder. And of course, if I will change it to the normal slashes in Unix-like system, it will have a very different meaning, because dot and slash means explicitly mentioning current folder, and then subfolder BBB, CCC, DDD. And here is this file created. Particularly in Java, what can you do? You can always use normal slashes, and if this will actually need to be have backslashes in VMS and Windows and similar systems, they will be converted to backslashes automatically. But if you are careful, you can use file.separator property to check what is considered as a separator between subfolders. when you convert this data structure of folder inside folder inside folder just as a delimited string. So that's about these things. So then, starting with more recent Java versions, you can also sometimes use Java Neo package not.io from input output, and here means non-blocking input output. And how where is difference? For example, if you try to read something using Java standard reader and there is nothing to read, then this method is hanging on execution of this method or blocking, and it doesn't go forward. But when you do with concurrency and other things, you may decide to do something like this: try to read. If there's nothing to read, continue. And that's what this package does. So if you try to read, there's nothing to read, all these methods still continue, you just do not get any data. But also what this non-blocking IO package provides, pass file system objects, which may be more handy when you need to manage file system objects in your Java application. So you are not required to use these non-blocking readers writers from this package, but you may decide to use these file system objects as a more useful and easier to handle management objects to manage files in your file system. And here is example of object serialization, which may be useful for your teamwork. And as soon as you say that your particular class implements serializable interface, you are allowed to convert your objects into stream of bytes, and then you can write these streams of bytes to write your object somewhere, for example in this case in file, and then you can read this object back from file and you get your object from outside world. What is important about object serialization and deserialization is what I mentioned already about unique identifiers for and unique class paths for your objects, because when you talk about object serialization and deserialization, then this difference between high abstraction layer and low abstraction layer is very important, because if you do not have this unique identifier, then only thing how can you understand that this object belongs to this class is its name of this class. Let's take this other thing as well. So here we say that this class implements serializable interface. We have one very simple internal structure for all object of this class, string called name, and then we create file output stream object to write these files, and then we just write our date of object using object output stream writer. And when we run it, we see here some binary data. What we see here is that this object refers to employee class, that its internal structure is Java-lang string object, and value for this Java-lang string object is following. But only thing how I can distinguish in this case that this object belongs to the employee class is class name, and class name, especially in the file package, is not unique enough. And of course we can look it in binary format. So here how it looks in binary format. But if we generated identifier, then this serialized object also includes this unique identifier, I think somewhere here. And then of course resolving and reading this object back from this stream of bytes here saved in a file is much more safer. And for example here, when you deserialize it, you see that we got this employee object back from this data file. And here again, what is very important, that object do not contain its data and methods. Methods are inside definition of class. Object contains only reference to this class, hopefully globally unique identifier, and then actual data with reference if these actual data are other objects like Java string. Again, it refers to Java string, that I am object of the string class, and then actual data. And you get actual description what this object is, what this object can do, only from the definition of the class. But if you cannot establish this link between your object and between your definition in the class in virtual memory, then of course you will not be able to tell what these data structures means and what methods you can actually use to deal with this particular object. So I told this already, how you convert data structure inside data structure or folder inside folder and delimiters already. And that's not all differences. Other difference is that when you deal with text-oriented stream of data, and text-oriented means that if you look on them and interpret this binary data as a text, then you see mostly text, you don't see something what cannot be shown as a text. What was this file called? Employee. But in which machine I created in this machine. So, if this is text, then when you try to interpret all this stream of bits or bytes as a text, you see readable text. And if you don't see much of readable text, then of course it is not considered text, it's considered some binary data. So for text, what is important for different operating systems, that there are different naming conventions, what you consider line break. And in general, there are two different characters or bytes, because it can fit into single byte. Consider it as a line break character or byte. And why in Java it's different, but in C character is in length of the byte. So one is called line feed, and you can represent it as a \n or 0a in hexadecimal or 10 in decimal, and so-called carriage return \r 0d in hexadecimal, 13 in decimal. And in general, you have all 3 or 4 possible combinations of these characters to be used as a delimiters for line breaks. Either line feed or carriage return, or line feed carriage return, or carriage return or line feed, or so 4 these combinations. But if you look on the most popular ones, then of course the most popular one is still Microsoft Windows if you do not consider mobile phones and mobile devices like real computers. But if you look only on IBM PC compatible computers, then Microsoft Windows inherited this from VMS, and similar systems, they use carriage return and line feed characters together to mention or to use it as a line break character. But for Unix-like systems, like different kind of BSD systems, some other Unixes, MacOS and Linux, it is just line feed character. And if you use read line things or read till to end of line, then you may ignore them, because depending on kind of operating system, it will read everything up to line break, and if line break is different, you will just not see them. But if you do something like read bytes or whatever, then you need to know how many bytes or characters may represent this line break, and you can get property of this using system.line separator method to check what is considered proper line separator in this operating system. And that's about these differences. Do you have any questions or comments about this?